When we think of math, we usually think of numbers. For example, we think of things like 5 plus 6 equals 11. We think of maybe things like 4 times 5 equals 20. We think of numbers. Numbers are math. They kind of go hand in hand. But we don't realize that until we get older, that a big part of math too is also the alphabet, as in letters. For example, we could say x plus 6. This x here, which a lot of people hate when the alphabet starts being a part of math, but this x here is called a variable. A variable is any picture or any letter or any symbol at all that takes the place of another number. Basically, all we're doing here is taking any number, x, and we are adding to it 6. So we could say, for instance, that if x equals 1, then we would get a 7. If x is 2, we would get an 8. And we could plug any number in for x because all we know is that whatever we are plugging in for x, we are going to add 6 to that number. So a variable is a very big part of math. So one way that we use variables is you all are familiar with patterns, I would assume. So a lot of times when we look at patterns, we look at a table called an input. I'm just going to write in and an output table, meaning that whatever number we put in, it's like going through a number machine. We're going to do something to it to get to our output. So if I was looking at an input-output table and I put an input of 1 and an output of 4, an input of 2 and an output of 5, and an input of 3 and an output of 6. So what I'm asking myself is, what is happening to this 1 to get to a 4? What is happening to this 2 to get to a 5? And what is happening to this 3 to get to a 6? So when I'm looking for that, I'm looking for the rule for the pattern. A lot of people just want to write plus 3, which is true. It is plus 3. Each of those would be plus 3. But one shorthand way you can write this is to actually write x plus 3 or any variable plus 3. If you wanted to, you could write a smiley face plus 3. As long as this right here could represent any number, because we just want to say that any number that goes into this input, we will need to add 3 to it. So we've seen examples of variable expressions. For example, we looked at one earlier that said x plus 3, and we knew that anything could take place of that x. Well, sometimes a variable can work a little bit differently. Sometimes we may have an unknown number, but we actually know the solution to the problem. So that gives us a little more information. When we have that little bit more information, we can actually figure out what our variable stands for by working backwards. In this case, what we would do is we would take 5 minus 3, and we would get that our variable was the same as 2. This is called, when we have something like this, x plus 3 equals 5, that's called an open sentence. Because it's a number sentence, I'll write that down. Open sentence. Because that's a number sentence where we have an open spot that could either make the number sentence true or false. If anything besides the number 2 is put into that particular number sentence, that would be false. If the number 2 is put in, that would be true. So that is why we call it an open sentence. So you may be wondering, when would something like this be useful? Well, let's look at this particular problem situation. It says, Mrs. Thompson baked her husband, Mr. Thompson, that would be me, some cookies. She ate 37 of them before he got home. Let me just tell you, she likes cookies, and sometimes I don't get too many of them. And there were 9 left. So when I think of that problem, um, I think of 37. First of all, I think of subtraction because we see that word left, and it kind of makes us think subtraction. So I think I started out with 37. She ate, we see this word some. That's our variable. She ate some. Do we know exactly how many she ate? No, but she ate some. So in place of some, in this particular case, I'm going to replace some with an x because I don't know how many she ate. So I can say that x is some number of cookies. But in this particular case, I do know the answer, so I can say that she ended up with 9. Now, we could obviously solve for the answer because we know that x plus 9 should give us our 37. We could actually find it in this case. So I want to take this a little bit further. If we had something like what we just saw, 37 minus x equals 9, there's actually a couple different ways we could write that. Think back to fact families. We know that subtraction and addition go hand in hand with one another. So besides writing it like 37 minus x equals 9, we could also say 9 plus x equals 37. That would also be true. We could also say 37 minus 9 equals x. And we could also say x plus 9 equals 37. In all 4 of these cases, this x stands for exactly the same number.